So with this problem, we're going to go ahead and factor using synthetic division. That's a tool for us to factor. The only thing though is if we're going to use synthetic division to try and factor, we do need a 0. So we've got this function, we've got x equals -2, we're going to try and see if -2 is actually going to be a 0. So we're going to go through that synthetic division process. So I've got the -2, that's my 0, I'm going to put that on the outside. I'm going to go with my coefficients. Now, if you look, I go x cubed, x squared, x to my constant term. I have all those terms in there. I'm not missing anything, so I don't need any placeholders. I'm going to put my coefficients, 1, -5, -2, and 24. All right, so those are my coefficients of that polynomial. No placeholders needed. Now, we're going to start with our synthetic division process. Drop the 1 down. You need a number to start with, so we're going to start with 1. Then it's that process again of I'm going to multiply my outside numbers. I'm going to add my inside numbers. So 1 times -2 gets me -2. Add your insides. -5 plus -2 is -7. Multiply your outsides again. You end up getting 14. Add your insides. -2 and 14 is 12. All right, multiply your outsides. That's going to get you -24. When you add your insides, you end up getting 0. Remember, that represents my remainder. Now, since my remainder is 0, this is actually good. This is what we wanted. That now means x equals -2 is a 0. Now, if I know my 0, I now know a factor. X plus 2 is my factor. Right? Remember, synthetic division is a way for us to factor. Right? So we're going to factor out this x plus 2. And when we factor out this x plus 2, we're left with these coefficients, 1, -7, and 12. Those represent stuff. The 12 represents a constant term. The -7 is my x. And then the 1 represents my x squared term. So what this now means is that I can take this x plus 2, and I can multiply it to this polynomial, x squared minus 7x plus 12. That right there is what I started with. The x cubed minus 5x squared minus 2x plus 24 is now factored to x plus 2 times x squared minus 7x plus 12. Now we're not done with this problem just yet. I'm going to look at that quadratic that was left over, that x squared minus 7x plus 12. I'm going to factor that. I'm going to factor that one more time. So I'm going to use my box method. All right, and that factors as x minus 3 and x minus 4. All right, so now I have everything. I started out with that first 0, x minus 2, or x equals -2. My factor was x plus 2. I got that quadratic. I factored it one more time as x minus 3 and x minus 4. Remember, the reason we do this stuff, the reason we want to go ahead and factor all of this stuff down is we can now have our zeros. Factored form gives us a lot of information. Standard form does not, doesn't really give us much. When it's in factored form, we can identify every single 0. So now my zeros are going to be x equals -2. We already knew that. My other 2 are 3 and 4. And we should have 3 zeros because we started with a degree of 3, 3 third degree, 3 zeros, 2 turning points. We have everything that we need.